Hello, everyone, and thanks for joining this session. Today, I will be talking about NVIDIA 100 H100 GPU. Uh, Here, I will be covering how exactly NVIDIA H100 GPU is widely used in various AI applications, and due to its high computational power, or memory bandwidth, and transformer engine. So I would begin going in detail about the Metalamba models are optimized for running on NVIDIA H100 GPUs, leveraging its capability for efficient inference and training. The H100 provides several advantages: massive computational power. It has a massive computational power, use Hopper architecture featuring 80 billion transistors, supports transformer engine to accelerate LLM training and inference. Then it provides high speed memory as well, where it offers 80 GB of HBM3 memory with up to 3.35 TB bandwidth, crucial for our Llama models. Then it supports FP8 precisions, and the transformer engine is H100 enables faster computation using FP8 and mixed precision without sacrificing accuracy. NVLink and multi GPU scaling. In this perspective, uh, Meta Lambda model can be distributed across multiple H100 GPUs using NVLink and tensor parallelism. Then optimized for Python, PyTorch, PyTorch and deep learning framework. H100 is highly optimized for PyTorch, which Meta uses for Llama training and inference. Moving on, and just would like to also convey that for training Llama models, H100 accelerates gradient calculation and reduces memory bottlenecks. And for inference perspective, H100 FPA8 and sparsity support allow faster and more efficient processing of larger scale models. NVIDIA H100 GPU is widely used in various AI applications, and due to its high computational power, memory bandwidth, and transformer engine, here is where mostly commonly utilized in case of large language model and generative AI. Meta Lambda, Lambda 2 and Lambda 3, then OpenAI GPT-4, GPT-5 in training inference, Google Gemini and DeepMind's AI models. Then, as part of AI model training and deep learning, think, used by OpenAI, Google, uh, DeepMind, Meta, and Microsoft for training multimodal and large-scale AI models. Support framework like PyTorch, TensorFlow, JAX, optimized with CUDA, helps reduce training time by 3 to 5x compared to a A100 GPU. So that's the point to be noted why H100 has advantage uh, over A100 GPUs. Having said that, AI inference and deployment perspective, cloud provides the cloud providers like AWS, Azure, Google Cloud, and Oracle uses H1 and H100 GPUs for serving AI model efficiently. A startup uses it for fine-tuning and inferencing LLM model and vision models. Computer vision and image video processing. In, here it is used for self-driving cars like Tesla, Waymo, NVIDIA Drive. Then medical imaging AI, a radiology, pathology, or genesis, satellite image analysis, climate, agriculture, defense perspective. Then AI for healthcare and drug diversity, health and drug discovery, use in potential in protein for folding research, then accelerate AI-driven drug and discovery, genomics and personalized medicine AI. Then in financial AI and risk modeling in perspective, here it is used in factory automation, warehouse robotics, and Boston Dynamics, Tesla, Optimus, drone, and defense AI. So it is used in autonomous system and robotics its perspective. Then comes AI powered search and recommendation system, Google search, YouTube recommendations, Facebook, Instagram, TikTok, uh, liking AI driven feeds, e-commerce AI like Amazon, Sof, Sophie, Alibaba. Last but not least, it the type of how exactly this is helping in case power AI as part of scientific computing and supercomputers. Power powers AI research in physics, chemistry, astrono- astronomy used in scale computers. So that's so basically scientific and computing and supercomputers where H100 is being used. Now moving on to what are the different features. supported by NVIDIA 100 and NVIDIA A100. Architecture perspective, it's a Hopper architecture where H100 and Ampere A100 as part of A100. Transistors 80 billion and 54 billion, and then computer performance but perspective 4x faster than A100 as baseline if you speak. Then other things have been mentioned over here. Just memory type HBM3 it is in H100, HBM2E in A100. Power consumption 700 watts. Then in case of NVIDIA is 400 watts. Moving on, key difference and the advantage of H100 over A100. Performance boost for A1 training and inference. H100 is 3 to 5x faster than A100 for training large models like GPT, Llama, and Gemini. FP8 supports or in H100 drastically improves inference speed without losing precisions. Transformer engine in H100 and accelerates LLMs makes it ideal for generative AI. Better memory and bandwidth perspective, H100 has 3.35 terabyte memory bandwidth, 67% more than A100. 80 GB HBM3 memory allows larger batch size for training inference. Then computer vision and medical AI, faster image analysis, AI inference, chatbot, search assistant, best for low latency inference. Then comes faster multi GPU scaling with NVLink 4.0, lower bandwidth AI training, fine tuning, mid size model, so overkills, but effective in A100. As part of energy efficiency and cost consideration, H100 consumes more power, 700 watt versus 400 watt from A100, making cooling important. As part of the cooling important. Uh, then high cost but greater speed reduces overall training time, saving money or cloud resources. Lower budget AI training, fine tuning, mid size models, overkilling, but cost effective. Cloud AI overloads used by AWS, Azure, Google Cloud, still widely used cloud, no? And power and cooling limitation needs advantage cooling 700 watt, easier to manage 400 watt as part of A100. In nutshell, if budget allows, H100 is best choice for cutting edge AI ML workloads. and the A100 is still useful for cost consciousness team, but it's failing behind in large AI models. So that's what I thought of discussing on H100 and what is that, why it is recommended and over in the current uh, models. Thank you. Thanks for joining.